Welcome to a lesson with Dr. Powell. Let's take a look at an example of Green's theorem along a path here going where it's a square going with diagonal running through 0, 0, and 1, 1. Okay, but we're also going to be thinking of it going clockwise around. How is that going to change things in our computation when we go clockwise? Well, when we go clockwise, then really what we're after is we want the orientation dy dx instead of the orientation dx dy. So that when we think about this, we're kind of thinking backwards in terms of area for orientation, because a frontwards orientation where you have x before y, x literally before y, means counterclockwise. Okay, and to top that off, if you do a negative, if you reverse direction, all your drs are going to be changed signs, so you should end up getting a negative result, and so it makes sense to pick the dy dx to have a negative result for area as well. Okay, so let's see how that might work here in this particular case. We first have our differential one form, which is xy dx plus x dy. Now, we change this vector field to the one that we can find area with using Green's theorem. So to do that, think of this guy right here as f, and think about you're looking for df. That's going to be, after taking a dot product, fx dx plus fy dy, just thinking of it that way. So quite literally, that would be y dx plus x dy. And then you're going to be wedging it on with dx. Notice you can ignore that one, it's just the x here. And look, it's the right one we wanted. We wanted dy dx because we're going clockwise. So we have, so from this first part, we have x dy dx. From this part right here, notice that you just take a dx of that. So it's really just dx wedge dy, but we need to take the negative of that because we want it to be dy dx. So we end up getting, we just need to integrate x minus 1 with respect dy dx, but since we're done figuring out what this is with the orientations, we can drop the wedge, and it doesn't matter if we rewrite it as dx dy or whatever. Order doesn't matter anymore at this point when we're just doing the straight integration. That's just for the setup here. Okay, so we're ready to integrate x minus 1, and we're just going 0, 1, 0, 1. So with respect to x, this is with respect to x, this is just x squared over 2 minus x, and we're going from 0 to 1, which would just be minus a half right there for that one. So yeah, minus a half. And then for the y, going 0, 1, it's just like multiplying by 1. So really the result is just negative a half. Thanks for watching.